All right, let's pick up where we left off last time in 5.5 and continue finding the area bounded by two graphs. Uh, there's going to be no graph presented to us this time. We're going to have to either draw it or find the information that we need without drawing the graph. So let's start with number 15, y equals x squared minus 1, y equals negative x plus 2, x equals 0 and x equals 1 defines my region here. See if we can sketch a quick graph of that. Make it 1 to 1. Something like that. And then 2, negative 1. So it's going to come down like this. And I'm interested in, this goes through negative 1, 0, and 1, 0. I'm interested from 0 to 1 here. This part of the graph right here where the line is above the parabola. So that's going to go 0 to 1. And then upper function is the line minus lower function is the parabola. And so this is going to be 0 to 1, negative x squared minus x plus 3 dx. And so I get negative x cubed over 3 minus x squared over 2 plus 3x evaluated from 0 to 1. It's negative 1/3 minus 1/2 plus 3 over 1. Make those all have a common denominator of 6. Negative 2/6 minus 3/6 plus 18 over 6 is 13 over 6 for my area. Let's look now at number 17. Number 17 says y equals x squared minus 4x plus 3. Y equals 3 plus 4x minus x squared. And they don't give me any other boundaries. So I'm going to have to find the points of intersection to see where the bounds are here. So x squared minus 4x plus 3 equals 3 plus 4x minus x squared. Bring this negative x squared to the side with the positive x squared to make everything positive. That forces everything to come to the left. Factor out my common factor of 2x. And that gives me x equals 0 or x equals 4. So my boundaries here are 0 to 4. If I stick in a number between 0 and 4, this y1 at 1 is going to be 1 minus 4 is negative 3, plus 3 is 0. This y2 at 1 is going to be 7 minus 1 is 6. So y2 is greater than or equal to y1 everywhere on this interval. So this is going to be integral from 0 to 4. 3 plus 4x minus x squared minus x squared minus 4x plus 3 dx is 0 to 4. 3 minus 3 is 0. 4x plus 4x is 8x. Then I have minus 2x squared dx. That's going to give me 4x squared minus 2/3 x cubed from 0 to 4. That's going to give me x squared over 3 times 12 minus 2x 6 minus x 2/3 x squared. Yes. From 0 to 4 is 2 times 2 is 4 times 4 squared is 16 is 64 over 3. And then when I stick 0 in, that's 0. Okay, so 64/3 is my answer there. Let's just check that. 64 minus 64/72 over 64, 128 over 3 is B12. 192 minus 128 over 3 is 64 over 3. Yes. Okay, so let's look at number 19. Number 19 is y equals 1 over x squared, y equals 0, x equals 1, x equals 5. Quick sketch. Both sides are above the x-axis and approach the horizontal asymptote. Y equals 0 here. I'm only interested in 1 to 5, which is this little area right here. So we're going to have integral 1 over x squared from 1 to 5. It's going to be integral x to the negative second dx from 1 to 5 is x to the negative first over negative 1 from 1 to 5 is negative 1 over x, 1 to 5, negative 1/5 plus 1 is 4/5. Now at number 23. Says f of x is equal to x cubed plus 4x squared. And my g of x is equal to x plus 4. This one's a little more challenging because our polynomial is of higher degree, and so we have more possible points of intersection here. Let's go ahead and see what's going on. So we have from, let's see, x cubed plus 4x squared equals x plus 4. X cubed plus 4x squared minus x minus 4 equals 0. Squared times x plus 4 minus 1 times x plus 4 equals 0. X plus 4 times x squared minus 1 equals 0. X plus 4 times x plus 1 times x minus 1 equals 0. X equals negative 4. X equals negative 1. X equals 1. That gives me, but I need to go from negative 4 to negative 1. And then I need to go from negative 1 to 1 with boundaries. for the bounded region, it's going to look something like this. This is -4, and this is -1, and this is 1. I'm interested in this region plus that region, called this R1, and this R area, area 1 and area 2. My total area is area 1 plus area 2. So going to have cubic minus the line. So this is f minus g of x dx. And then this one is g minus f of x dx. Write these down here again, since I'm going to scroll down. Okay. Let's just confirm that if I stick in a number between -4 and -1, like -2, f of -2 is -8, plus 16 is 8, and g of -2 is 2, and 8's bigger than 2, f is bigger than g. Let's stick in a number between -1 and 1, like 0. F of 0 is 0, g of 0 is 4, g is bigger than f, so I have the order of subtraction correct here. -4 to -1, f minus g, so that's x cubed plus 4x squared minus x minus 4. Dx plus -1 to 1. That's going to be g minus f, so that's x plus 4 minus x cubed minus 4x squared dx. That's going to be -4, -1, so that's 1/4 x to the 4th plus 4/3 x cubed minus 1/2 x squared minus 4x from -4 to -1 plus 1/2 x squared plus 4x minus 1/4 x to the 4th minus 4/3 x to the 3rd from -1 to 1. Sticking -1 in for my upper bound here. This is going to be 1/4 plus, minus 4/3 minus 1/2 plus 4 minus, stick in -4 for my lower bound here. 1/4 of 64 times 4, 256 plus, and then negative 256 over 3. This is 120. That is 64. And then minus half of 16 is 8. And then plus 16. And then that is plus, and then this is 1 for my upper limit. This is 1/2 plus 4 minus 1/4 minus 4/3 minus, and then stick in -1. It's going to be 1/2 minus 4 minus 1/4 plus 4/3. Okay, let's simplify each set of parentheses. So this is going to be common denominator of 12. This is 3/12 minus 16/12 minus 6/12 plus 48/12 minus 64 plus 16 is 80. 80 minus 8 is 72 minus 256/3. And then this is plus common denominator of 12 again, 6/12 plus 24, no, plus 48/12 minus 3/12 minus 16/12 minus common denominator of 12, 6/12 minus 48/12 minus 3/12 plus 16/12. Okay, so those zero each other out right away. And see what I can get here. So this is going to be 51 minus 22/12 minus 216 minus 256/3. And then we have plus 48 minus 16 is 32/12 minus, so minus a negative 32/12. That's going to be 64/12 plus 51 minus 22/12 minus, and then this is going to be a negative, that's 256 minus 216 is 40. It's going to be plus 40/3. When I multiply that by 4/4 to get a denominator of 12, it's going to be 160 plus 64 plus 51 minus 22/12. And that gives me see here, 86, no, 42, and 51 is 93. 160 plus 93, 253/12, and that shouldn't reduce anymore. So I think that's it for that one. Let's go ahead and look at number 27. F of x is e to the 0.5x. G of x is a negative 1/x. We have x equals 1 and we have x equals 2. don't think that we're going to get any nice point of intersection without graphing here and using our graphing calculator. So e to the x over 2, it's a positive exponent, so it's going to rise to the right. Even though it's a fraction, it's going to grow slowly. E to the 0 is going to be 1. So 1 e to the 1/2 and 2 e to the 1st. And then this is negative 1 over 1 is 1. So square root of, see which is bigger. This is negative 1 over x. So we're down here the whole time. So I know which one is bigger because that's all below the y-axis. Now I want the area between these two curves here, like so, from 1 to 2. So that's 1 to 2 of e to the 0.5x minus a negative, like so, 1 to 2 e to the x over 2 dx plus 1 to 2 1 over x dx. Need a 1/2 here and a 2 to balance it out. It's 2e to the x over 2 evaluated from 1 to 2 plus ln of the absolute value of x evaluated from 1 to 2. So that is 2e minus e to the 1/2 plus ln of 2 minus ln of 1 is 0. So that's my exact answer is 2e minus 2 root e plus ln of 2. You can get a decimal approximation for that if you'd like. Let me go ahead and throw in the next problem here, number 41, just because it's kind of similar. And I'm going to do it 2 ways, even though the book only tells you to use calculus. I'm going to draw a picture here. They give us the ordered pairs, 0, 0, 2, 3, 4, 0, and 2, 3, 4, 4. And it makes a triangle here, a right triangle. And it has a base of 4 and a height of 4. So my area formula tells me that that's 1/2 base times height. That's 2 times 4 needs to be 8. Now let's do that with calculus. That this line right here, let's find the slope, is y2 minus y1. Talking about this line right here that makes the hypotenuse. So y2 minus y1 for x2 minus x1. 4 over 4 is a slope of 1. It goes through 0, 0, so this is the line y equals to x. This line is y equals to 0. So I have from 0 to 4 on x. Y upper minus lower is x dx. So that's going to be 1/2 x squared from 0 to 4. 1/2 of 16 minus 0 is 8. which is exactly the same answer we got from geometry. All right, we'll stop there for this video. We'll come back next time and we'll talk about consumer and producer surpluses. These are going to be some economics business applications. Then we'll have a whole section on various application problems after that. So a couple more videos in the section to wrap up this chapter, but probably a short video next time. There's just going to be consumer and producer surpluses, and I'll do those separate from the rest of the applications. All right, so see you next time for the next video.